Welcome to my YouTube channel. My name is Dr. Charles and tonight we are going to talk about the periodic table in chemistry. So in today's topic, we are going to talk about the definition of the periodic table. We then talk about atomic and mass number. We talk about an orbital or an atom. We talk about the first element, and then we shall see a table showing the atomic number of elements, the electronic configuration and valency of elements in the periodic table. We talk about how to determine the valence of an element. We talk about the group of an element. We talk about the period of an element. We talk about metals and non-metals, how to determine them. So the definition of the periodic table. The periodic table is a table of chemical elements arranged or organized in array. Array means order of their atomic number, usually in rows and columns. So the periodic table is comprised of rows and columns with different elements arranged in the order of their atomic number, like you're seeing in the downer picture. That is a typical representation of a periodic table. So it has, we talk about atomic number, mass number, and the orbital. Atomic number is the number of protons or electrons in the nucleus of an atom. So that is the atomic number. From there we talk about an atom as the smallest invisible particle of matter, and it is comprised of a nucleus. The nucleus has the protons and neutrons. Protons are positively charged particles in the nucleus of an atom, and neutrons are neutral particles. They don't have any charge. We talk about revolving electrons. So this atom is comprised of revolving electrons. These electrons are negatively charged particles revolving around the orbital or an atom. So we talk about mass number, which is also known as atomic mass, as the total sum of the number of protons and neutrons in the nucleus of an atom. So a note, you just have to know that protons and neutrons are of the same number. If protons are 6, electrons are also 6. So atomic number can also mean the number of electrons or protons in the nucleus of an atom. Like you seeing an atom, as I said earlier, is comprised of a nucleus. A nucleus has both protons and neutrons, and also electrons revolving around the nucleus. We move to the first 20 elements of the periodic table. An element, by definition, is a substance that cannot be decomposed or broken down into simpler substances by any ordinary chemical means. And elements are fundamental materials of which all matter is composed of. There is nothing on earth that doesn't have elements. Elements like hydrogen, elements like magnesium, elements like calcium, even our bodies, they are matter. They are examples of matter, and they have many elements which are inside there, and which are of a vital importance. There are 118 known elements in the periodic table, but here we are to talk about how to memorize about 20 of the 118 elements of the periodic table. So we are going to basically look at the 20 first elements of the periodic table and how to memorize them quickly using a simple song. Heavy Henry loves Betty but could not offer full needs. So Mary and Simon pressed sex continuously and people complained. This is how we are going to sing the song. Heavy Henry loves Betty but he could not offer family needs. So Mary and Simon pressed sex continuously and people complained. So each first letter of the words shows an element, and those letters are highlighted red, as you can see. Like for first H, it represents hydrogen. Okay, so you choose first letters from each word. Heavy, you choose H. Henry, you choose H. Love, you choose L. Betty, you choose B. B will represent an element, as we are going to see here, a table showing the atomic number of elements, electronic configuration, and the valency. So this table there has the atomic number. Atomic numbers range from 1 to infinity. Okay, there are these very normal numbers like 1, 2, 3, 4, 5, 6, 7, 8. They show the number of electrons or protons which an element has. So we choose our first letters from our song words, The Heavy Henry Loves Betty. So from H of heavy, you get that H, up to C, the complained, you choose C to represent calcium, the real elements. And then we talk about the symbol. You write the symbol. The symbol is different from the formula because a symbol means a simple text presentation of something without any number on it, but a formula should have, okay, may have a number on it, though some elements have the same symbols and same formulas. The symbol is the same as the formula, which is okay. But you first look at the formula. First look at the symbol, and then you get to know the formula. Like for oxygen, the symbol is O and the formula is O2. We talk about the electronic configuration. The electronic configuration shows the number of shells which an atom or an element is having. And then after there, we see the valency. Let's talk about them in details. Well, how to determine the valence of an element? Well, for a valency, refers to the number of electrons that must be lost by an atom of an element to obtain a stable electronic configuration. A stable electronic configuration. We base the electron configuration to know the valence of an element. We base on electronic configuration by taking the number of electrons in the outermost shell, as we are going to see here. Remember, electronic configuration shows the number of shells acquired by an element. And well, valences range from 1 to 4. Though you can find elements with more than a valence of 4, like chromium 6 and so many others, but basically valences range from 1 to 4. And when you find out that there are more than 4 electrons in the outermost shell, we always subtract that number from 8, because 8 represents the number of electrons of a stable atom like that of noble gases. So we move to how to determine the group of an element. So a group is a column or vertical arrangement of elements in the periodic table. So that vertical arrangement, like when you in the first image you saw the periodic table, but the columnar arrangement, that over the columnar arrangement or the vertical arrangement of elements shows the group. The group represents the family of elements with the same chemical and physical properties. Elements of the same group have the same number of electrons in the outermost shell of their atoms and form the same type of bonds. Groups are written in Roman numerals and they range from 1 to 8 in the periodic table. So group range from 1 to 8. There is no group that is beyond 8. All elements fall in those groups. It may be in group 1, group 2, group 3, group 4, or group 6, 7, or 8. We move to how to determine the period of an element. Well, a period is the horizontal or row arrangement of elements in the periodic table. So the rows of the periodic table show period. And periods can be the number of shells. It is the number of shells which are occupied by electrons. Okay, the shells occupied by electrons of an atom. It represents the number of shells that an element has, and it shows the number of electron occupied shells of an atom. We move to like calcium. It has 2 to 8 to 8 to 2 when you write the electron configuration. So when you count the number of shells, okay, when you count the numbers after each full colon, you will find out that there are 4 numbers. So that makes it to be in period 4. Periods range from 1 to 7 in the periodic table, and there is no element that is beyond period 7. They are all falling in between 1 and 7. We move to metals and non-metal. How to determine metals and non-metal. We first talk about metals. For you to know whether something's a metal or non-metal, we depend on the number of electrons in the outermost shell. All metals are electropositive and have valences ranging from 1 to 3 in their outermost shell. So you base on what you see in the electron configuration. When you see that the number of electrons, they are from 1 to 3, some element that has 1 electron in its outermost shell, some element which has 2 electrons, another one having 3, those are metal elements. So metals range from 1 to 3, like calcium. It has the last shell, the outermost shell, having 2 electrons, hence a metal due to having 2 electrons in the outermost shell. So metals are solid at room temperature and are collectively known as cations due to their nature of losing electrons to form positive charges. So these metals have that nature, that tendency of losing electrons in order to form positive charge. Remember, when you lose electrons, you remain with protons, thus remaining with the positive charge, because we said protons are positively charged particles. Like cations, like calcium 2, it has 2 positive, so it has lost electrons. That means that it has lost 2 electrons to form a positive charge. We move to nonmetals. How to detect nonmetals? All nonmetals are electronegative and have valence electrons from 4 to 8. So nonmetals have valence electrons from 4 to 8 when you write the electron configuration, and then you find out that the last shell having like 4 electrons, 5, 6 to 8 electrons. That means that element is a nonmetal. So nonmetals gain electrons to attain the negativity and form anions with a negative charge. So these ones, they gain electrons, though they form a negative charge, but that negative charge with its number shows the number of electrons which they can gain. Okay, like silicon, it is the electron configuration of silicon is 2 to 8 to 4, thus making silicon 4 with a negative charge. So that is an anion. So thank you so much for viewing this, and if you would like to get the full notes about this presentation, you just have to fill in the form below the description, and then I'll get straight to you and contact you, and you have notes straight to your mobile device. Thank you so much.